How to architect a secure, cost-effective AWS solution from scratch. Let's start with a blank slate. As a best practice, we will build our entire infrastructure using CloudFormation template. The first component is the VPC. You want to choose a range that is not already in use in any of your AWS accounts. The reason is that if we ever need to connect two VPCs together, we want to make sure there are no conflicts on the CIDR ranges. For this example, we'll be building our highly available infrastructure across two availability zones. Some regions have more than two availability zones, so you can build your infrastructure across more AZs. The more AZs you use, the higher the availability of your infrastructure. However, you will need resources in each AZ, so it will increase your costs. The first set of subnets we will build are public subnets. The main difference between a public subnet and a private subnet is that a public subnet has direct access to the internet via an internet gateway, and instances in a public subnet can be directly accessed from the internet. The private subnet, on the other hand, does not have direct access to the internet and can only initiate access to the internet via a NAT gateway. Instances in a private subnet cannot be directly accessed from the internet. Next, we will build a set of private subnets. We will use this layer to host our application, using EC2 instances or containers. It's important to note that as we build these subnets, we are also creating security groups for each subnet or group of subnets that restrict traffic. In the case of these application subnets, we will restrict traffic so that resources in these subnets can only be accessed from within the public subnets. The next set of subnets we're creating are private subnets to host our databases. It's good practice to create separate subnets for the databases so that we can further restrict access to them. In this case, we will use security groups to make sure that only resources in the application subnets can access the databases. The next resource we'll create is IAM roles. Just like you can use IAM to allow users to access the AWS console, you can use them to create roles for specific resources or groups of resources and restrict which actions those resources can take. You can create roles for certain EC2 instances, Lambda functions, and other resources. In our example, we will run our application on containers running on ECS for simplicity. The next step is to create a database instance. For our example, we'll use Aurora. We want to launch the Aurora instance in one of the database subnets we created earlier. Aurora automatically creates a failover replica and a separate AZ, so if the main instance fails, it automatically fails over to the replica. If needed, you can also create separate read replicas to offload some of the workload from the main database. The next component is the load balancer. In this case, we're using an application load balancer, or ALB. At this point, we have an application that is accessible to our users. Users can access the ALB directly from the internet, or you can create a hosted zone in Route 53 to use a custom domain. Even though the ALB can scale across your AZs in case of high loads and traffic, it is not ideal because the security features of the ALB are somewhat limited. The next step is to add a CDN to our application so we can cache some assets closer to the end user. CloudFront sits in front of the load balancer, providing an additional layer of security. Now that we have CloudFront, we can separate the front end of our application and host it in S3, assuming it's all static. This improves performance because the files in S3 get cached into CloudFront and get served to the end user faster, but it also lowers the load on our application as it will have fewer requests. Another thing we can do now is configure CloudWatch alarms and have those alarms pushed to us via SNS, either via email or text messages. The next layer of protection is a web application firewall, which filters and monitors incoming traffic. You can add a number of rules so only certain traffic can get to your application. At this point, we have 2 points of entry into our application, CloudFront and the ALB. The ALB lives in a public subnet and thus has a publicly accessible address. AWS recently announced CloudFront VPC Origins, which allows you to connect your CloudFront distribution to resources inside a private subnet. This pushes the ALB to a private subnet, eliminating the risk of someone having the ability to access your application via the ALB. our alb now becomes an internal alb. One other service you can use for additional security is WAF bot control. This service helps detect bots accessing your application and blocks them. AWS Shield Advanced is a premium DDoS protection service, and you get access to a DDoS response team when there's an attack. It's expensive to run, but might be worth it for critical applications. The typical way to get access to your resources in a private subnet is by having a bastion or jump host in one of the public subnets. In this example, you can't really access a container in ECS, but if your application runs on EC2 instances, then you may want to access them via the bastion host. The problem with a bastion host is that it is a single point of failure. If it dies, then you can't access your resources in the private subnets. Ideally, you wouldn't need to access those anyway, but for the sake of this example, we'll say you do. This means that you now have to worry about having a highly available bastion host with an autoscaling group. You can now replace those bastion hosts with Systems Manager's Session Manager. Session Manager allows you to directly SSH into your EC2 instances without the need for a bastion host. The only requirement is that your EC2 instances run the Systems Manager agent, which most images have. Let's say your application produces large amounts of data and you need to store this data in S3. You would probably simply push this data into your S3 buckets. However, pushing the data directly into S3 is not ideal. What really happens when you try to push data into S3 is that the data is transferred over the internet via the internet gateway. This is not ideal because your data is not secure and it adds additional latency to the process. Instead, what you want to do is create a VPC endpoint for S3 so that you can transfer data from your application to S3 via the AWS internal network. This makes the data transfer faster and more secure. An additional security tip is using AWS Secrets Manager to store sensitive data such as database credentials, SSH keys, and other sensitive information that is used by the application. Instead of storing this information in the server or as part of the code base, you store it in Secrets Manager and the application can retrieve it when needed. And that concludes our 3-tier infrastructure setup. Of course, things get much more intricate and complex from here, but this establishes a basic foundation that can be easily adapted. Easy ways to learn more. We've got complementary services designed to assess and optimize your environment. Immersion days are tailored sessions ranging from brief overviews to full-day workshops conducted jointly by our team and AWS. Trainings can be customized to address your company's specific needs and skill levels or provide hands-on experience with AWS services. Well-architected reviews are thorough evaluations of your workloads against AWS practices and identify areas for improvement in cost, performance, and security. A cost and security compliance assessment is conducted through Kalos, which ensures your infrastructure is both cost-effective and compliant with latest security standards. Follow Stratus 10 CEO on LinkedIn to stay up to date with AWS and gain perspectives from an AWS partner, or email us to get more info. Stratus 10, an AWS advanced partner, specializes in migration, app modernization, DevOps, and managed services. We also offer cloud visibility in a SaaS platform to help AWS users understand and optimize their AWS usage, costs, and security compliance. Kalos is also available via the AWS Marketplace. Thanks for watching.